Hello, so today we're going to talk about how to solve a quadratic equation using the completing the square method. So this will be different from when we factored in a previous video, and this requires our use of the complex number I, so make sure if you haven't watched that video yet you do, otherwise certain components of this won't make any sense. Again, following along in the Glenn Algebra 2 2018 edition textbook, we're in section 3.5. So completing the square, this is where you're trying to write an expression as a perfect square. So it'll be x plus or x minus some number, the result being squared. Numbers are perfect squares if it follows this format, x squared plus bx, where we divide the bx, the b value, by 2, and then we square that result. That creates this as a perfect square. So that will be illustrated more like this. So if we want to find c for each one of these to make it a perfect square, well, what we do is we divide 18 by 2. We get 9. We square that, we get 81. So then this becomes x squared minus 18x plus 81, which can be rewritten as x minus 9 squared. So same thing for the y squared plus 22y plus c. So if we divide 22 by 2, we get 11. We square that, we get 121. So it'll be y squared plus 22y plus 121. That's then y plus 11 squared. And then finally, the last one, z squared plus 9z plus c. So 9 divided by 2 is just simply 9 halves. We square that, we get 81 fourths. So this would look as z squared plus 9z plus 81 over 4, which is the same thing as writing as z plus 9 halves squared. So obviously if the number in front of the middle term is odd, this becomes a little bit more annoying because you get fractions there. I generally find from personal experience that if I recognize the middle term is an odd number, or that there's a number in front of the x squared or whatever the variable squared term is, that's most times completing the square is going to be kind of annoying at that point. I'd rather just use the quadratic formula, which will be another video you can watch. Your call, your own personal choice. This video is only really going to focus on dealing with it when it's even terms in the middle, because again, like I said, my personal preference is to use the quadratic formula for all those other cases. So again, we need to isolate the x squared and bx terms to solve this kind of equation. So any other number, the c value, needs to move to the opposite side of the equation. And then we complete the square from there so we can isolate the x expression. So that will look like this. We have x squared minus 6x plus 12 equals 19. So the first thing we're going to do is we're going to subtract the 12 over. And we're going to get x squared minus 6x and then equals 7. Now we're going to leave a space there because we're going to fill that space in. Because now we're going to go ahead and complete the square. We divide the middle term by 2. 6 divided by 2 is 3. We square through, we get 9. So that'll be plus 9. Now, we can't just add in a number into the equation and just hope everything works out nice. What we do to the left side, we must also do to the right side. So if I add 9 on the left, we have to add 9 on the right. Now I can rewrite the x squared minus 6x plus 9 as x minus 3 squared. And 7 plus 9 is 16. The advantage here is now we essentially have the x term isolated. There's a single x value. So we can get rid of the square by square rooting. So we get x minus 3, and this one's nice because 16 is perfect, so it'll be plus or minus 4. So when we solve, we have to add 3 to both sides, so it'll be 3 plus or minus 4, which when we separate out gives us positive 7 and negative 1. If 16 wasn't a perfect square, that would be a square root in that spot, so we'd have to simplify that as far as possible, and then we can't really separate out to give two separate answers. It's better to leave it in a condensed form. But if it's a perfect square and there is no square left over, we should always combine the terms to get actual numbers. So this is how we solve by completing the square. Now obviously something like this, if it gives you nice numbers, you could have factored this instead. But not all expressions can be factorable. There could be situations where you just simply don't get numbers that actually work out the way you want it. So for this one, again, we have to add 3 to both sides first. So we get z squared plus 12z equals 11. Again, we divide the middle term by 2. You get 6. We square that. we get 36. And that's what we add to both left and right sides of the equation. So, the left side is now in the perfect square form, so it'll be z plus 6 squared, and then equals 47. Because we squared the expression, so we have to square root to get rid of it. So we get z plus 6 equals plus or minus. Now, the square root of 47 is not perfect, and 47 itself is also prime, so there's nothing we can do with that. It's just simply square root of 47. So we subtract the 6 over, and you always want to put that number in front of the plus or minus, so negative 6 plus or minus square root 47. Again, because the square root of 47 is not a whole number, not a perfect square, we can't simplify down to a whole number there, so there's no need to combine with negative 6, so we'll just leave it in the separate form like this. Alright, so we have a problem like this, so same idea, we need to move the 10 over. Always want to leave it as the variable squared and then the middle term together, move the constants to the other side of the equation. So when we subtract the 10, we get a squared plus 4a equals negative 6. So we divide the middle term by 2. 4 divided by 2 is 2. We square that and we actually get back to 4. So we had 4 on both the left and right hand sides. So the left side is in the perfect square form, so it'll be a plus 2 squared. And again, always remember it's just simply the sign of the middle. That's why it's plus there. And then whatever we got after we divided or before we squared, that's what's going there. Equals negative 2. So when we do our square root, well, we now have the square of a negative number. This is why it was important to have first watched the video on completing complex numbers, because here, square root of negative 2, that's fine. It gives us an I square root of 2. Because square root of 2 can't be simplified, so that's as far as it goes, but we do need to account for the negative. That's why we put an I there in front. Plus or minus I, so don't put the I as like before the plus or minus. We subtract over the 2 to get a equals negative 2 plus or minus I square root 2. Alright, so that's completing the square process. It's really not terrible as long as you're working with even numbers for the middle term. And technically, if it's an odd number, it really isn't the worst thing in the world. You're just getting fractions. They kind of get annoying if you're not careful with the problem. Like I said, generally in those cases, if it's an odd number in front for the middle term, I just find it easier to use the quadratic formula. Also, notice each one of these problems, there was no number in front of our variable squared. It was a 1 there. If there's a number there, you have to take that into account and deal with it as well. So like I said, quadratic formula is generally your best option for those kind of problems. Just easier to work through for something like that. Your choice though. If you want to see how to do stuff like that, feel free to talk to me in class, or feel free to either Google or go to Khan Academy for that. Alright, so we're going to talk about the quadratic formula in the next video, so I will see you next time.